Hey, welcome back. And today I want to talk about machine learning development and the software development. What's the difference? If you are a software engineer or you are a machine learning engineer or data scientist, you may be interested in this topic. Okay, so let's start. You may, if you are a data scientist, you may sometimes hear like a lot of engineering best practices, and people actually want to apply those to data science. And especially when you are developing a machine learning model, you will find some of them are really not compatible. For example, in software development, they usually want to write a lot of test cases, but in the model development, sometimes it's very hard to write test cases. So what makes this is just one of the different things. So what makes these two fields so different? In my opinion, these two fields are just two different disciplines. They are dealing with very different problems, and just happen to use the same tool, which is programming, to as a tool to solve their problems, but their problems are very different. Okay, so what's software engineering? Basically, it's like you give in input, and you through your input to the program you write, then your program will basically act as a function, very deterministic function, and give you output. So by doing this, you are kind of it's easy to test your software, the piece of code that you write, because you already know like expected output, and so that's why you can easily to write test cases. And because of this kind of a thread, it's easier to break down the the big chunk of the big task to very small subcomponents, because you know how to break down already. That's a very deterministic. And when you break the big task to small subcomponents, you also know how to expect your output. You have given input and you have expected output. So it's easier to plan. On the contrary, in the machine learning, in the data science world, it's about building model. It's about, especially now, it's about building deep learning models. That's basically quite complex, and it's very sometimes contains a lot of uncertainty. Usually, what data scientists do is to gather the data, training data, and train your model on your training data, and expect your model will be performed well on a similar data when you really deploy your model, because you will get a new input, and this input is supposed to have a very similar distribution as your training data that you train your model. Your model basically learn from your training data, like how it should perform, how it should behave. But there's really no way to predict how the model will really react, because they contains, that's basically, you can see the model as a black box. It contains so many different neurons, and because of these kind of things, these very complex math operations, and so that's why it's very hard to expect the output. And sometimes during the model development, you will have a lot of hyperparameters. You have a lot of different architectural decisions to make. And in order to overcome that, you need to iterate very fast. You need to train your model very fast, so that when you train your model very fast, you will be able to verify those assumptions, if those assumptions are correct or incorrect. If that's not incorrect, then you move in another direction. Let me give you one example. Maybe you're training a deep learning model. Let's say you want to train a transformer, a 12-layer transformer, but maybe the model can perform better when you reduce the number of layers but increase the number of the the dimension. Basically, you make the model wider, then you perform better. How do you know? Actually, no one knows that until you do the experiment. So in the data scientist, the most important thing is not breaking the big problem to a lot of subcomponents, is to experiment. It's to experiment to verify your assumptions. You will have definitely a lot of assumptions, but it's very hard to tell if it's correct or not. That's the trend of the deep learning, the data science now, because we don't know the exact solution. We don't have a heuristic to solve that. If we know that, we already write a program to solve by ourselves. But because we don't know that, we don't know how to really solve that, so we employ deep learning models and want these models to learn from the data. For example, how to build a image recognition model. How can you write a rule to classify if this is apple, if this is orange, if this is computer, and there are maybe 10,000 classes. How do you write a rule? It's very hard. It's basically, even you write one rule to classify one kind of apple, what if there's another kind of apple? So that's very hard to do by writing program, but it's easier to do by training a deep learning model to predict that. So because we don't know how to do that, so that's why it's very hard to write test cases. It's very hard to break the big task down to a lot of subcomponents that's testable. So that's why what really makes the software engineering and data science so different. And this will just make the way you solve the problem, the way you plan your project a little bit different, because in the data science, it's very hard to foresee the future. It's even like you just plan for a week. Sometimes a week's already too long, because maybe you planning to train a deeper model, but when you just the first try, you train a little bit deeper model, then a little bit deeper, like a few deeper model, then it does just they don't perform well. Maybe you will decide not to go in this direction, you go another direction. So before you really try some experiments, and you don't know how to plan that, and it's really like what other people say we should do, maybe 1 day sprint in the machine learning or data science field. Basically, it's just do experiments every day, and then the model train your model overnight, and another day you go and see the results, analyze that, and to decide what's the next experiment you want to run today. Yeah, so a little bit fragmented my thoughts. Basically, yeah, so some just get some of my thoughts, and so other people also talk about this, so I just wanted to make these videos. And so yeah, that's all I want to share with you today. If you would like to receive more software engineering, data science, technology news and analysis, like this video. Don't forget to subscribe, and other than that, I will see you next time.